Hi everyone, welcome back to my YouTube channel. Today we are diving into the graph, a fundamental data structure that's super useful in many real-world scenarios. Let's break it down.
A graph is a collection of nodes, also known as a vertex, connected by edges. Think of a graph like a network where each point is connected to others. For example, social networks, maps, and even web pages are models as a graph. There are different types of graphs. Directed graph. Edge have a direction, like a one-way street. For instance, to follow a relationship is directed because it only goes one way. Undirected graph. Edge have no direction, like a Facebook friendship where both users are connected mutually. Weighted graph. Each edge has a weight or cost. Imagine a map where edges represent the distance between cities. Unweighted graph. All edges are equal. Think of social network where each connection is simply present or absent without any cost. Next we talk about an adjacency matrix. An adjacency metric is a 2D array, where each row and column correspond to node in the graph. The value at given cell I, j tell us whether there is an edge from node I to node j. Here, how it works. If there is an edge from node I to node j, we place 1 in the cell. If there is no edges, we place a 0 in the cell. Let's construct the adjacency matrix of our graph. There is no edge from A to A, so we put 0. There is an edge from A to B, so we put 1. There is an edge from A to C, so we put 1. There is no edge from A to D, so we put 0. The other rows follow the same pattern. Now, let's move on to the graph traversal algorithm. The first one we will discuss is breadth first search. Let's start with node A. First we insert node A into the queue. Since the queue follows the FIFO rule, we immediately dequeue node A, making it the first node in our result. Now our result list starts with node A. Next, we visit all neighbors of node A, which are B and C. We enqueue both B and C into the queue, following the FIFO principle. The next node to be dequeued is B, so we dequeue B and add it our result. Now our result list is A and B. Next we check if node B has any unvisited neighbors. In this case, B only has neighbors that have already been visited or are already in the queue, so we move on. We dequeue again, and this time node C come out of the queue. We add C to our result. So now our result is A, B, C. We then check if node C has any unvisited neighbors. We find that node D is an unvisited neighbors of C. So we enqueue D into the queue. Finally, we dequeue once more and node D come out of the queue. We add D our result list. Now we check if node D has any unvisited neighbors. Since there are no unvisited neighbors left, we finish our traversal. So the final BFS traversal result is A, B, C, D. Now let's talk about depth first search. In DFS, we use the stack to keep track of nodes. The stack operates on default principle, meaning the last node added will be the first one removed. We start by pushing node A onto the stack. Then we pop node A from the stack, making it the first node in our result list. Our result list now begins with node A. Next we visit all the neighbors of node A, which are B and C. We push them both onto the stack. Since C was pushed last, it will be the first to be popped. we pop node C from the stack and add it to our result list. Now our result list is A and C. Next, we check if node C has any unvisited neighbors. We find that node D is an unvisited neighbor of C, so we push node D onto the stack. Now, we check if node D has any unvisited neighbors. Since there are none, we go back to the stack. Finally, we pop node B from the stack as it was added before C and add it to our result list. Since there are no more unvisited neighbors and the stack is empty, our DFS travel is complete. The final DFS result is A, C, D, B. So to recap, we learned how to represent the graph using adjacency metrics. We explore two essential graphs, traversal algebra, BFS and DFS. Both BFS and DFS have their unique strength and application, depending on the problem you are trying to solve. I hope this video has given you a solid understanding of graph representation and traversal technique.
If you enjoyed this video, don't forget to like, comment and subscribe. See you in next video.